Welcome to this short presentation on how HeatQuiz works. So first of all, what is HeatQuiz? Well, HeatQuiz is an application intended to teach, train, and practice the fundamentals of heat and mass transfer. By using a game-based learning approach, it tries to target bachelor and master students. HeatQuiz makes use of learning paths, and by use of these paths, the students will get a clear overview of what the course will look like, and besides that, they have direct access to all the learning material. This material consists of video lectures, small quizzes, lecture notes, homework assignments and their solutions, and some other learning material. I will quickly demonstrate what the user interface of HeatQuiz looks like. So here we have the learning path for conduction, and each gray block targets a specific relevant topic, which helps to understand the concepts of conduction. Taking the first block as an example, it gives an introduction to Fourier's law, and attached to this element, you get to find a video lecture about this topic. Furthermore, a PDF file of the lecture slides is available, so you can go through them after watching the lectures. And lastly, a short quiz is present to test your understanding of the topic. In these quizzes, different types of game modes are available, which will be explained in a second. The yellow blocks contain the homework assignments and are more complex than the short quizzes. These homework assignments are there to train your understanding step by step to the level that will be required on the exam. In the pink blocks, the solutions to the homework assignments can be found. But in order to be able to access these blocks, you first should have finished some quizzes. In this case, I should finish the fifth quiz with an 80% success rate before getting access to the solutions. And so the idea of each map is that it gives you a clear overview of what and when will be taught. What distinguishes HeatQuiz from other quizzes? Well, as said before, everything is contained into one learning path, but besides that, it has customized game modes that are adapted to the taught topics. Currently, we are mainly using multiple choice questions, keyword questions, and clickable questions, but in the future, some newer game modes will be available as well, such as energy balance questions and more. So first explaining the multiple choice questions. So here we have a task where we have to set up an energy balance and select the correct answer from the available options. In this case, only one is correct, but there are some questions where multiple answers might be correct. So we'll pick the answer that we think is correct. And indeed, it is. In the case we've gotten it wrong, or we don't understand why this is the correct answer, a large number of the questions have a PDF file attached to it where the answer is explained as well. And then we have the keyword questions. For this question, we have to give an expression for the Reynolds number by use of the keyword. So let's do this. As you can see, some of the keys contain another set of keys to give the power of that specific variable. We can use the bracket key to define the denominator. So our answer is correct, and again, a PDF solution is attached where you can find an explanation on why this is the answer. And then we have the clickable questions, which are used for the heat transfer course to practice what a temperature profile or heat flux profile looks like. So for this task, we have to define what a temperature profile will look like outside the wall. In the figure, it's shown that the highest temperature is on the left side of the wall, so therefore we know that the temperature will decrease when moving from left to right. You will learn from the convection lectures that when moving in the left direction, the temperature will approach the ambient temperature with a zero gradient slope, so therefore we'll pick this option. Then we should specify whether the profile is steeper in the fluid or in the solid wall. In general, fluids have a lower thermal conductivity, which means a steeper gradient, and therefore we define the left part to be steeper. Again, the same story here, but then the other way around. And then when moving into the right direction of the wall, the fluid will approach the ambient temperature at that side, and it will have a zero slope again. So therefore we'll pick this option. So our answer is correct, and in the case that it wouldn't have been correct, we could have seen what the solution would look like. But how effective is HeatQuiz actually? This graph shows the performance of students on the exam and the number of games that they have played. In general, it shows that the students who made more use of HeatQuiz performed better overall on the exam. But the most right bar also shows that playing a lot of HeatQuiz is no guarantee for a good performance on the exam. The quality of answering is also very important. Here you can see that if students start to perform well on the tasks in HeatQuiz, they also start to perform better on average on the exam. So if you use HeatQuiz, you should use it to learn something from it, and not to use it because you have to. This explains in short how HeatQuiz works, but the important thing is that you start practicing yourself. And you really should keep in mind that the quizzes are a supplement for understanding different phenomena. The homework tasks and lectures are just as important.